This is a quick review of right triangle trigonometry. This video focuses on finding missing side lengths in a right triangle. We already know about SOHCAHTOA. This is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you need a little refresher on this, I would recommend watching the video on right triangle trigonometry ratios that I have made. Now we're going to use these ratios to find unknown sides in a right triangle. So these are very handy if you know an acute angle in a right triangle and you know one side of a right triangle. Now, if you know two sides of a right triangle, you can always find the third side by using the Pythagorean theorem. So this provides a way of finding a missing side length if you only know one side, but you do need to know one of the acute angles in the right triangle. Here is an example. It's a 30, 60, 90 triangle because I see one of my acute angles is 30, and if you know the one acute angle, you know the other because both acute angles add up to 90. I also know the hypotenuse length, it's 10, and I want to find the length of the side opposite the 30. Now we kind of already know the answer to this. If you are up on your 30, 60, 90 triangle rules, this is a special right triangle, the 30, 60, 90. So if you forgot how that works, there is another video you could be watching that reviews how to use these 30, 60, 90s. But in this case, I know the shorter leg, the side opposite the 30-degree angle is the shorter leg, and the shorter leg is half the hypotenuse. So I already know what that x is. That x should be 5. But I want to solve this another way. I want to solve this using right triangle trigonometry. So I'm going to label all my sides relative to the angle I know, that 30-degree angle. So hypotenuse is 10, and the opposite side is that x. The adjacent doesn't really come into play here. I only want to find the side I know and the side I don't know. Now, opposite and hypotenuse, that's in sine, SOHCAHTOA. So the sine of theta, sine of any angle, is the opposite over the hypotenuse. So in this case, my angle is 30 degrees, opposite is x, hypotenuse is 10. Apply algebra by multiplying 10 to both sides. Your x will be 10 times the sine of 30. Now the sine of 30 degrees is just a number, but most of us don't know what that number is. We're going to have to use a calculator. Now I'm looking at the Virginia version of the Desmos calculator here. You want to make sure that you are in the correct mode for the degrees or radians that you're using. And with Desmos, they have a little wrench here. So I'm going to want to make sure I'm on degrees. If you're using the Virginia version of Desmos, it's supposed to default to degrees, and it's showing that here. If you were to just use regular plain old ordinary Desmos, I believe it would default to radians. If you don't know the difference between these two things, well, you will someday. So for today, though, we're just using degrees. So verify that you're on degrees. Even if you're in this Virginia version, I highly encourage you to always check. You never know when they might change the default values. So you do that first. Okay, you want to see how to use these trig functions, these trig ratios rather. So I'm going to click on Show Keypad. And then I'm going to go over to the word functions. And we've got a whole bunch of different functions here, but it's defaulting to the trig functions, which is what we want. I believe our equation was 10 times the sine of 30. So I'm just going to click on sine here and type in 30. And as we can see, that's 0.5. Every trig student knows the sine of 30 degrees is 0.5. I like to use this sometimes as a little test case to make sure I'm in the right mode, because watch what happens if I'm in radian mode and I type in the sine of 30, I get some weird, crazy thing. So it's just a good way to know you're in the correct mode. So I just thought I'd point that out. And we want 10 times this, right? So 10 times the sine of 30, which is 5. X equals 5. Which is exactly what we expected, but we got this another way using trig functions. Let's look at another example. In this example, I have an angle 53 and I've got two sides. And instead of labeling all my sides, I'm just going to label the ones I need. The side I know and the side I want. The side I know is my opposite the angle, and the side I want is adjacent. So opposite and adjacent, SOHCAHTOA, that's the tangent. TOA. Tangent is opposite over adjacent. So my theta here is 53 degrees, so let's do our substitution. Tangent of 53, opposite is 25, the adjacent is x. Now this algebra, if you recall working with proportions, we can actually swap the tan 53 and that x. It all works. X is 25 over tan 53. Tan 53, just a number. What number is it? I don't know. Let's use our calculator. Again, I always do a little quick check. I'm in the right mode, degree mode. And it's going to be 25 divided by, bring up my keyboard, go to functions. This time I want tangent, and the tangent of 53 degrees to the nearest tenth, say that's about 18.8. So our x is approximately 18.8. All right, my final example here. So I know the adjacent, I know the hypotenuse. Adjacent hypotenuse, that is cosine. Cosine is adjacent over hypotenuse. Making my substitution, cosine of 41 is 55 over x. And then I can do that swap thing again. And x will be 55 over the cosine of 41 degrees. I don't know what the cosine of 41 degrees is, so I'm going to use the calculator again. And I always check whether I'm in the right mode, so I'm checking again. Yep, still in degree mode. And so it's 55 divided by, click the keyboard, click functions. This time I'm looking for cosine of 41. By the way, if you are at a keyboard, like a physical one you're typing out like I am right now, you can actually just type in cos, C-O-S, and the parenthesis, it will figure it out. But our x is approximately 72.9. And there's our hypotenuse. I hope this has been helpful to you. Just find the two sides, the one you know, the one you want, apply the trig ratio, and you have it.